let's start with the problem. What's the problem of now, the energy problem now? We have a high reliance on coal and also have a high unstable energy supply within the developing countries and high emissions of greenhouse gas. So the global situation now is that India is an example of LMICs, and that they have a frequent power cut, and we need an extra maintenance cost for companies. Whereas China, there's a lot of weather conditions, and also, although there are a lot of solar panels, but we have an unstable and insufficient power supply and causing some energy blackouts. So we have a solution now. So this is our sun tracking solar panel. It's called Helios, and we'll do a demonstration. So imagine the sun is on this side, then the solar panel will automatically fall on this side, so it reflects to the sun side. And then, on the probably like 5 or 6 o'clock, and then the sun is on this side now, then the solar panel will be shown onto the other side. So what happens is that this will be installed on the roof of the buildings on different campuses in Hong Kong U with some plants and modeling some of the greenery within the rooftops. Okay. Right. So we've gone through, so another aspect is that we have a battery there. So what's this battery's function is that we can use the energy from the battery when there's insufficient amount of sunlight, and also when there's a high wind, so we can use the energy from the battery, so we don't need to rely on this all the time. And the solar panel can recharge this on sunny days. Why do we need this? Is that it's renewable, inexhaustible, and we can also produce more solar energy. So we can see that there is a decrease in cost of solar energy right now, and then from over time we can see that it's getting cheaper, and we can get more energy from the solar panel. So there is a really high significance of solar panel within Hong Kong U is that Hong Kong has an average sunlight hours of 1,600 sunlight hours, and then the battery in the pallet can be recharged during the day, and energy can be stored in the battery with low maintenance cost. We can achieve carbon neutrality within Hong Kong U and can be implemented in different stages, such as the Centennial campus that we're in now, the main campus, and several residential halls in Kennedy Town. So the significance of solar panel within Hong Kong U is that there's a lot of space for implementations, such as the Centennial campus here. We've got the medical campus there, near Sandy Bay, and also main campus, which has a lot of sunlight. Next slide, please. Thanks. The market research is that we found that there's a total income per year of £2,000, and also around Hong Kong dollars is $9,750 from our market research, stating that the solar panel is on a decreasing trend of cost, and also that we have a high tax rebate. So there's a lot of potential solar panel here. As you can see, there is a bus that has a solar panel installed. Why is this good? Because it can produce less emissions. We can charge some of the car's energy and also implement it for some power resource. And this is actually a form of corporate social responsibility with an attractive mindset. So Hong Kong U has we can say there is a decrease of 20% of cost using the solar sun tracking panel rather than fixed, and that Hong Kong USD has done a lot, and we can see that Hong Kong U can do a little more job. Hong Kong U produces 260 watts, 5 watts per square meter, and that we from our market research, by implementing more, we can actually put them in, we can actually increase the cost, the energy outage by 35 to 40%, and can emit less CO2 gas. So solar panels for conventional is up to 40% better. So there's a growth rate of 45% every year for solar panel, and it has grown to 230 gigawatts now. And that we can see a decrease of greenhouse gas for 17 to 24.7, and energy use on the other hand, we can see that it drops by 13%, which is quite a lot compared to before. So we can see that as solar energy is solved by the model presented here, and also although the installation cost is high, we can see that there is a decrease in cost in the long run due to economies of scale, and it provides a viable energy source when we install it. There's a lot of roof there. We can achieve carbon neutrality This because that from here we can actually install the solar panels. Then we install solar panels, it will deduct the use of, even minimize the use of the solar fossil fuel system, and then we can actually use the plants here as a supplementary to the solar panel that can be installed. Here's the potentiality. So Hong Kong U has a lot of greenery surrounding it. There's a lot of sea. There's a lot of greenery. From here is the CPD campus. We found that the land here is really underutilized, and that by installing this, we can achieve the carbon neutrality by having some of the system here complementing the roof. So it can power the whole building, and what this does is actually insulates the whole building itself, so that we don't have any fossil fuels that we can use. So we can see that Hong Kong U can do a lot of catch up. For example, some of the schools here, they have a lot of solar panel, some of the farms. Then the potential on the bigger scale is that the rooftop can collect solar energy, and then we can improve public health and reduces the use by decreasing some of the fossil fuel gas such as nitrous oxide, carbon dioxide, and water. Okay, so why is our design viable is that it is safe and sturdy, it's cheap, and also more sustainable. And also, if we have excess supply of power, we can actually put it back to the national grid of Hong Kong. Here are some of the risks and dangers.
Can I ask quickly, what you refer to as underutilized space, I would refer to as quite beautiful green space where I might relax during my lunch hour. Have you considered how you might balance sort of these enjoyable spaces with the obviously very commendable aim of increasing renewable power?
Let's go back to the slides.
Because that looks like a great source of power, but doesn't strike me as a relaxing space.
Okay, so we have actually seen some examples of the, let's say Centennial campus. There's a lot of greenery. We want to increase some of the space for utilization of solar panels. We don't mean that we will use 100% of the space, no. There's the trees there complement with the solar panel. Once they complement with the solar panel, for example, let's say we have 50% of the space. We might not install it here, but we might install it in some of the areas here. For example, you can see that from the main building there, there's a lot of sunlight. There's a lot of underutilized space. Like we can actually put some solar panels there.
You mentioned we can be carbon neutral as a university because of this. Did you run the metrics on that? Like, do you have tangible data of how much energy we need, how much our system would produce? That's question one. And my second question, which is, I think I asked this in the previous review as well. How is your system different from other solar panels, and why have solar panels in the past not always been moving around with the sun? Clearly somebody must have thought of that in the past and decided that it would be better not to do that.
Okay, so may I answer your question first? Okay, so your second question demonstrates like how we're different from other companies' solar panels. We can see that this sun tracking solar panel is like 40% better than the traditional one because it uses the sunlight's energy. For the real prototype, we actually automate this by using a lot of linear actuators, using a lot of equipment.
I think for the first question, like the calculation of like how much energy Hong Kong U uses, I think we could, we're not getting to this step yet, but I'm sure if we move on, we'll go to the Hong Kong University like finance services or like maintenance issues. We will ask them questions about like how much energy we use. So it's probably the next step we were going to do. So for the second part, like Edward just mentioned, it's 40% better than conventional solar panels because it receives sunlight from two directions. Like it's not just omnidirectional, like receiving sunlight from one direction.
So let's say that light is the... No, I understand that part, but I'm sure the engineers thought of that 30 years ago as well.
Well, so I've seen the system actually in other parts of the world. work a little bit differently. So they move with the sun, and then actually they reflect as mirrors. They reflect the reflection of the sun into like a turbine that produces the energy. So that's like has been around for a very long time. My question is, have you considered some of the innovations that are now kind of trendy and then talked about a lot, which is the application of solar, kind of like a foil on the windows? Would that be a possible solution instead of maybe installing the sort of ugly panels over greenery rather than that, or a combination of that? I know there's lots of question marks around it, but it's an innovative technology, and I think the campus is positioned in a little bit different space than other buildings in Hong Kong, so there is a direct light on the campus because we are so high up. So I wonder whether you've considered that.
This is an option that we might implement. For example, we can utilize some of the sunlight from the windows. For example, there are some of the building that, let's say they're tinted. We can actually use that as a power up the building.
I think we can definitely explore more of the option you just mentioned, because we all think that like this is a lot. There's a lot of possibilities in this project in capturing solar power in this way with linear actuators. So I guess it's a way we can explore if we move on.
Can I give you just one quick question? Please make the answer quick as well.
Yeah, I think what would have really been helpful in your presentation is, how much money would HKU save as a result of the solar panels? What's the cost of ownership of it? And what's the return on investment? And when would the university recoup that investment?
Can I add one to that? Is your project to design a new solar tracking panel, or is the project to put solar tracking panels in Hong Kong U?
Well, our main project would be the solar tracking panels around Hong Kong or maybe around the world, but of course we would like to benefit Hong Kong U. So our first maybe, let's say, actual prototype would be at Hong Kong U, where we have looked at the locations and looked at their possibilities. So I feel like the first step would be at Hong Kong U.
So it's a new type of solar tracking panel?
Yeah. Yes.
Cool.
Thank you very much.
So basically, we have done research on like how much money we save. It's about 20% like saved money instead of like not using solar panels and using these solar panels. It will be 20% of the savings. Yeah, 20% from the conventional like omnidirectional solar panels and the like sun tracking solar panel. And onto that question would be like, I think it's both of the, it's mixed, like two options of the both. So we're actually both designing the sun tracking solar panel, as well as we want to implement it into the campus for the long run. So yes. I guess it's.
So one very quick question and very quick answer, please.
One quick question. So thank you for your presentation. But my question is regarding structural, the weight issues. My concern is actually, have you discussed this with structural engineers? Because if the weight of it is too great, if you have so many panels and so much equipment on the rooftop, there are concerns with structural issues. The structural engineers would have to evaluate to see if the rooftop is actually capable of handling. So my question is, have you done your research on this aspect?
So we're considering that for now. We're in a design process that we can, after, let's say we have taken this project on board with some of the Hong Kong U leaders, we're actually like reflecting Tom's questions. How can we maintain an equilibrium of greenery and also the building and the weight? So now we can actually think about how we can solve this problem.
And actually, to add on his point, we've not actually asked advice to a structural engineer, but we've actually made like design like to cope with these risks and dangers. So it's not actually two pillars, it's rather 3 pillars to make sure it's steady under like strong winds or like typhoons. And also with this battery down there, it would be steady, and also there's more weight to the whole structure. So, but I guess we will ask the structural engineers for the exact calculation.
Yeah, the main thing is that the rooftop can handle the weight, the additional weight.